All right, cool. All right, so today we're going to be talking about SQLite and going over some cool examples. I'm Chris Kwame.
Tyler Hargett.
Hunter Houston.
So why use SQLite, and to be more general, why use an embedded database on a mobile device in the first place? SQLite's the most easy to use and easy to implement embedded database. Your data will obviously be persistent and stored locally and easily organized because it is a SQL database. But the most important benefit is that it'll speed up the user's interaction with the device. Instead of having to query a database in the cloud constantly and waiting for these results to show up, you can make one big query and store those results, thus allowing the UI to be updated very quickly.
So for iOS, SQLite is very easy to use because it's built in. It uses C++, while the iOS programming uses Objective-C, and they work well together. And then the same thing with Android. The SQLite is built in using just a simple library that you can reference in the code.
Now the SQLite versus core data. SQLite uses C++, as Hunter said, but it's better understanding for interactions with the database because you're actually queuing SQLite and not just it being automated like core data is. And then there's less learning curve for using SQLite if you've already used a MySQL or SQLite, like similar thing. And then core data is actually built on top of SQLite 3, so it's very easy, it's built in. There's significant performance benefits because it's supposed to be the perfect one for it, and it's more automated because it's easier to make the tables and use and store the data. And then there's a graph interface of the tables and relationships between the data. And now we're going to go to the core data example and have queries.
And then later.
And now I'm going to take you through a example of core data in iOS. So here I've already included the core data model, which is required if you're going to use core data. The album, artist, and label are the entities. They're also essentially the tables of a MySQL database. So for album, we have the attributes of released and title is stored as a string, and release is stored as a date. And then also artist has hometown string, name string, and labels has those attributes. And then to add the relationship between them, you simply switch over the editor style to the graph and table, and you see this graph representation of the tables you just created. So you have label and its attributes, and then its relationship. I've already added the relationship, so I'm going to click on the relationship to artist. And on the top right, you see its settings. So it has a destination of artists. You can change that. You can have a delete rule, like MySQL. So you can have cascade, nullify, no action, or deny. We're going to stay with cascade. And then it can be either a one-to-one relationship or a one-to-many relationship. And then you can add those relationships, as many tables as you need, and that would be the model. That would be the database we're using for this project. And after you do that, you will create these classes of album, artist, and label. An album will import artist because it has a relationship to artist. And then the app delegate, you need to have a managed object context and a managed object model, and then persistent store coordinator. These three things allow one to add and manage your data you've stored. Then we're going to scroll down to create, and I'm going to walk you through how you create it. And so we have create here. So you have to grab the NS managed object context, which is self, and then so you're going to create a label, and then you're going to set that label to have a name, and you're going to create a date for that label, and then add that date, and that creates a date or a label. And then you create the artist object and the album object. Now down here you see this is where you set the relationships. So label has the artist objects, and then that will create the relationships. And then just to save the data, all you have to do is context save, and it automatically saves everything. And that is how you save data in using core data.
Now we're going to do an example in Android.
Alright, so here we put together a little Android to-do list application that uses a very simple database table that we create in order to store the to-do list. So you see here in the main activity, it will call the to-do DAO class, which I will click to now. So in this class, the database is actually created, which you can see right here. And in the to-do SQLite helper, the table is created. You can see that we have an integer primary key and then the to-do list, which is a text value. So this is our very simple 2-column table which adds a to-do list. And then over here in the click activity, once you click the to-do list, it is then deleted. So I have the app pulled up right here, which I will show you. So you click up here, you add a new to-do list item, you enter it in, have some homework to do, add it to the database. So this has now been added to our SQLite database. I go back to the main screen and you can see it's listed right here. And so whenever I click the homework item, it will then be deleted, and now our database is cleared again.